Right now, something unthinkable is unfolding at the edge of our solar system. The interstellar object known as 3I/ATLAS, a visitor from beyond our stars, has just done something no natural object should ever be able to do. It bent space-time, not figuratively, and certainly not as a poetic metaphor. NASA's instruments recorded an actual gravitational distortion around it, a measurable warping of space itself. And if that's true, then everything we thought we knew about gravity, mass, and interstellar travel may never be the same again. We are standing on the precipice of a new reality, one where the laws of physics are not just observed, but potentially manipulated by an intelligence we have yet to meet. Before we explore this breathtaking discovery, make sure you hit the like button, subscribe, and tell me your country in the comments. I love knowing where around the world you're watching from, because tonight, every one of us shares this moment together. We are witnessing a chapter of history that will be studied for centuries to come. This is a moment when humanity looked into the dark and saw the universe bend. For millennia, we have stared at the stars and wondered if we were alone. We looked for radio signals, for flashes of light, and for chemical signatures in distant atmospheres. We never expected that the answer would come in the form of a silent traveler, warping the very fabric of reality as it passed by our doorstep. The story begins quietly, as all great discoveries do. It didn't start with a bang or a broadcast. It started with a flickering pixel on a high-resolution screen. A few months ago, astronomers using the Subaru telescope in Hawaii were tracking the trajectory of 3I/ATLAS, the third confirmed interstellar object to enter our solar system. Following in the footsteps of Oumuamua and Borisov, 3I/ATLAS was expected to be another icy relic from a distant sun. The Subaru telescope, perched atop the frozen peaks of Mauna Kea, is one of the most powerful optical instruments on Earth. Its 8.2-meter primary mirror was designed to peer into the deepest reaches of the cosmos, but on this night, it was focused on a guest much closer to home. At first, it behaved predictably, a faint greenish glow, a smooth curve through the outer planets, moving faster than any comet we've ever seen. The greenish hue suggested the presence of diatomic carbon, a common feature in cometary bodies. Scientists calculated its hyperbolic orbit, confirming its origin from deep interstellar space, perhaps from a star system thousands of light years away. It seemed destined to be a footnote in astronomical journals, a brief visitor passing through our neighborhood at 150,000 miles per hour. But then during one of NASA's high-precision measurements, something happened that made scientists stop breathing. For a brief moment, a fraction of a second, 3I/ATLAS appeared to decelerate. This was not a slow drift or a gradual change. It was an abrupt, jarring shift in velocity that defied the vacuum of space. Not because of resistance, not because of dust or gravity from nearby planets, it slowed against empty space. In the frictionless environment of the void, an object in motion stays in motion unless acted upon by an external force. There were no gas jets, no outgassing of ice, no solar wind strong enough to cause such a stutter. The equations didn't add up. The mathematicians at the Jet Propulsion Laboratory ran the numbers again and again, hoping for a software glitch, but the data was cold and unwavering. Then almost immediately, the space around it rippled, as if the fabric of the cosmos itself had been pulled and released like a stretched sheet, snapping back into place. This was not a visual illusion. It was a structural event. Telescopes across the globe recorded it. From the high deserts of Chile to the orbital platforms above Earth, every lens pointed at 3I/ATLAS saw the same thing. The European Space Agency's Gaia Observatory confirmed gravitational lensing, a bending of light around a body far too small to cause such an effect. Gravitational lensing is usually reserved for massive galaxies or black holes, entities with the mass of billions of suns. For a rock barely a kilometer long to lens the light of background stars was physically impossible by any known standard. The James Webb Space Telescope, pointed nearby, detected micro-distortions in background starlight, subtle but undeniable. The JWST, with its infrared eyes, saw the heat signature of the object flicker and shift, not because the object changed temperature, but because the medium it was traveling through, space itself, was being distorted. And that's when the whispers began in the halls of academia and the bunkers of space agencies. Could 3I/ATLAS be creating its own gravitational field? Could something artificial, a technology beyond human imagination, be manipulating the very structure of space-time to move? If so, we aren't just looking at a rock. We are looking at a machine. Now let's pause and think about the implications. To most people, the term bending space-time sounds like science fiction. It brings to mind images of Star Trek or the shimmering portals of Interstellar. But in Einstein's universe, it's very real. It is the fundamental truth of our existence. Every object with mass bends the space around it. The more massive the object, the greater the curve. That curve is gravity. The sun bends space. The Earth rides in that curve like a marble rolling in a bowl. Even you, standing there, bend space-time by an infinitesimal amount. But for something the size of a small comet to distort light itself, even briefly, it would need an energy source beyond comprehension. To achieve the level of lensing observed by Gaia, 3I/ATLAS would have needed to possess the mass of a small moon concentrated into the size of a city block. Since the radar data showed the object was relatively low density, the only other explanation is that it was generating a synthetic gravitational field. NASA's Jet Propulsion Laboratory released a statement saying the event does not conform to standard gravitational models that scientists speak for. This is the bureaucratic way of saying, we have no idea what just happened. In the world of high-level physics, does not conform is the most terrifying phrase you can hear. It means the map of reality has just been torn up. Some speculate it may have encountered a gravitational wave, a ripple traveling through space from a distant cosmic collision. Perhaps two black holes merged millions of years ago, and the resulting ripple just happened to cross paths with 3I/ATLAS at the exact moment we were watching. Others think it might be made of exotic matter, a material so dense, so foreign, it naturally warps the space around it. Exotic matter is the stuff of whiteboards and theoretical papers, matter with negative mass or properties that violate the energy conditions of general relativity. If 3I/ATLAS is composed of such material, it would be the first piece of non-baryonic matter ever handled by the human gaze. But a few, including theorists at Harvard Center for Astrophysics, are entertaining an even more daring idea that 3I/ATLAS could be using gravitational manipulation as propulsion. This takes the conversation from geology to engineering. If true, it would change everything we know about travel between the stars. Imagine a ship not pushing through space with rockets or solar sails, but riding the folds of space itself. Instead of moving through the universe, it moves the universe around it, bending the cosmic fabric to shorten the distance. This is the difference between an ant crawling across a rug and someone picking up the rug and folding it so the two ends meet. For decades, this has been the holy grail of theoretical physics, the warp drive. In 1994, Miguel Alcubierre proposed a mathematical model for this, suggesting that a craft could travel faster than light by contracting space in front of it and expanding space behind it. The math worked, but the energy required was equivalent to the mass of Jupiter. And now, some are asking, what if 3I/ATLAS just showed us it's possible? What if the energy problem has already been solved by someone else? What if the comet we are seeing is actually a probe utilizing a propulsion system that makes our most advanced rockets look like primitive wooden wheels? Of course, NASA isn't claiming this. They cannot afford to be wrong about a discovery of this magnitude. Officially, it's just an unexplained gravitational event. But behind closed doors, something remarkable is happening. Data sharing channels between NASA, ESA, and the Japanese Space Agency have gone dark. Restricted access only. The public-facing servers that usually host raw telescope data have seen maintenance outages. The same happened in 2017 with Oumuamua when it briefly accelerated without any visible jet of gas or dust. But this time, it's different. This time, we have evidence that the very space around the object changed. With Oumuamua, we had theories. With 3I/ATLAS, we have measurements of the fabric of the universe itself. When I first saw the gravitational data released by the University of Tokyo, I felt a chill. It was subtle, elegant, and terrifyingly precise, as though someone had gently touched the universe and left a fingerprint. The data showed a perfect toroidal distortion, a donut-shaped ripple in the local gravity field. It wasn't the chaotic splash of a natural collision. It was geometric. It was designed. You see, 3I/ATLAS has been behaving strangely since day one. Unlike normal comets, it glowed from within rather than reflecting sunlight. Spectroscopy showed the light wasn't just reflected solar radiation, it was an emission spectra, meaning the object was generating its own photons from a source deep within its core. Its trajectory wasn't chaotic, it was deliberate, almost surgical. It didn't just tumble through space, it seemed to be following a path that maximized its exposure to the sun's gravitational well while maintaining a specific distance from the gas giants. And now, after this warping event, the glow has vanished. 3I/ATLAS has gone dark, invisible to optical telescopes. It's still there, detectable by radar, but its signature has changed completely. Scientists are calling it the blackout phase. It is as if the object has shut down or entered a low-power mode after its massive exertion of energy. It's as if the object slipped behind a curtain of its own making, a gravitational shroud that hides it from our view. By warping the space around it, the object may be creating a stealth effect. If light is bent around the object rather than reflecting off it, the object becomes effectively invisible to the naked eye. Some researchers at the Harvard-Smithsonian Center have noticed something chilling. Time around 3I/ATLAS seems to have dilated slightly. This is perhaps the most mind-bending part of the entire ordeal. The signals bouncing off it from radio telescopes took longer than expected to return by microseconds, but enough to suggest that the space around it has stretched. Let that sink in for a moment. If these measurements are correct, 3I/ATLAS isn't just moving through space. Plus, it's bending time itself. When we talk about time dilation, we're talking about one of the most profound consequences of Einstein's relativity. Clocks tick slower in stronger gravitational fields. Astronauts on the International Space Station age a fraction of a second slower than people on Earth because they are further from the Earth's mass, though their speed also plays a role. But to create measurable time dilation, you need immense gravity. A planet, a star, or a black hole. For a small object to achieve that, it is fundamentally impossible, unless it's doing something we don't understand. And that's exactly why scientists fear what comes next. Because if 3I/ATLAS can manipulate space-time intentionally or accidentally, what happens when it interacts with something else? What happens if it bends too much? Could it tear a microfissure in space, a pocket of warp time? Could it create, even momentarily, a bridge between here and somewhere else? These are not the ramblings of science fiction or the scripts of a Hollywood movie. These are real discussions happening in research labs tonight. Physicists are looking at the data and realizing that the boundaries between possible and impossible have been blurred. One physicist from MIT put it bluntly: if this isn't natural, then something out there understands the universe better than we do. They aren't just using the laws of physics, they are rewriting them. And that's the part that haunts me most. The realization that we might be children, playing with blocks while a master architect builds a skyscraper next to us. You see, throughout human history, every great discovery began with something that defied explanation. The strange orbit of Mercury gave us Einstein's theory of relativity because Newtonian physics couldn't explain why the planet's path shifted. A tiny anomaly in Uranus's movement led to the discovery of Neptune. 3I/ATLAS may be one of those whispers, but it feels different. It feels intelligent. It feels like a greeting from a civilization that has mastered the very foundations of the physical world. Some theorists believe we're witnessing a form of cosmic engineering, an ancient probe still carrying out its purpose. Perhaps it wasn't built to communicate, but to observe. Maybe it's been traveling for eons, passing through star systems, scanning magnetic fields, gravitational harmonics, and the architecture of space itself. It could be a scout, sent out by a race that has long since passed away, or one that is watching us right now from the safety of the void. And when it reached ours, something perhaps the sun's field or Earth's gravity triggered it. The light flash we detected weeks ago could have been a signal, a ping sent back to a distant home, the gravitational ripple, a form of propulsion or a byproduct of its internal power core. And now by going dark, it may be entering a new phase or preparing for something else entirely. It might be waiting for a response, or it might be calculating its next jump to a different star. It's humbling, isn't it, to think that we might be the ants watching a passing ship, mistaking its shadows for miracles. We see the ripples in the water, but we cannot conceive of the engine that made them. For those of you who remember the Apollo missions, you might recall that same feeling, the awe of stepping onto a world that had existed for billions of years, untouched by life. That same feeling is back tonight, but multiplied by a factor of 1,000. We are no longer the explorers, we are the observed. We are no longer the ones making the first move. We are the ones reacting to a move made by something else. NASA has now deployed the Deep Space Network to track 3 I/ATLAS beyond Mars's orbit. They are using every available dish, from Goldstone to Madrid, to keep a lock on the object's location. The object appears to be slowing again slightly, but without any visible cause. It is defying the laws of orbital mechanics. The only possible explanation is that it's altering the curvature of space around itself like a surfer adjusting the shape of the wave. If that's true, then for the first time in history, we may be witnessing technology that uses the laws of physics not as barriers, but as tools. Think about that. For centuries, humanity has fought against nature, against gravity, friction, and distance. We built engines to overcome gravity and heat shields to survive friction. We fought the universe to get where we wanted to go. What if another civilization learned to flow with those forces, not fight them? What if they learned to harness the elasticity of space like a musician plucking the strings of a cosmic instrument? What if gravity isn't a weight to be lifted, but a thread to be pulled? I often tell my students that science is poetry written in the language of mathematics. It is the attempt to describe the beauty of the world through the precision of numbers. But tonight it feels like the universe itself is writing a new verse. And 3I/ATLAS is the pen. The ink is gravity, and the paper is the void. Perhaps we've been wrong to assume that intelligence must look like us or think like us. We expected radio waves and mathematical sequences. Maybe the first real sign of advanced life won't come in the form of a message or a beacon. Maybe it will come as a ripple in the stars, a soft bending of the rules, a hint that someone else is out there playing with the fabric of reality itself. We have been looking for a shout, but we found a sigh. We have been looking for a footprint, and we found a ripple in the pond. So as 3I/ATLAS fades into the outer dark, leaving behind more questions than answers, I invite you to think about this. What if we just witnessed the future, not just of alien technology, but of our own destiny? Because if it's possible to bend space-time, then one day humans could cross the galaxy, not in millennia, but in moments. The stars would no longer be distant points of light, but neighbors. The vast distances that separate us from the rest of the universe would vanish. Maybe 3I/ATLAS isn't here to scare us. Maybe it's here to show us what's possible. It is a proof of concept, a demonstration from the cosmos that the cage of light speed can be opened. Do you believe 3I/ATLAS truly bent space-time? Or do you think the universe is simply playing tricks on our instruments? Is it a natural phenomenon we don't yet understand? Or is it the first sign of a galactic neighbor passing by? Tell me what you think below. Your theories are just as valid as anyone else's in this moment of collective mystery. And don't forget to like, subscribe, and share this video with someone who still gazes up at the night sky with wonder. Because someday soon, when we finally understand the riddle of space and time, we'll realize that the universe has never been silent. It has always been speaking to us in light, in gravity, in whispers that stretch across eternity. And now with 3I/ATLAS, we may have heard it speak for the very first time. The implications of this event extend far beyond the telescopes and the laboratories. If a physical object can manipulate gravity, it suggests that our understanding of mass is incomplete. We have long viewed gravity as a secondary effect of mass, something that just happens because matter exists. But if gravity can be generated or manipulated artificially, it becomes a technology. Imagine a world where we can create gravitational shielding, or where we can lift objects without energy loss. The energy density required to warp space, as 3I/ATLAS did, would be millions of times greater than anything we can produce with nuclear fusion or antimatter. This suggests the existence of a power source that we haven't even theorized yet. Furthermore, the blackout phase raises questions about cosmic sociology. Why go dark? If an object is passing through a star system inhabited by a developing civilization, is there a protocol for low observability? In the same way that human researchers use camouflaged blinds to watch animals in the wild, perhaps 3I/ATLAS is programmed to minimize its impact on our development. The sudden warping event might have been an emergency maneuver or a necessary correction that briefly broke its camouflage, allowing us a glimpse behind the curtain. If this is the case, we are not just being watched, we are being managed. As the object moves toward the outer reaches of our system, heading toward the Oort cloud and eventually the interstellar void once more, the scientific community is left in a state of feverish debate. Teams at the Large Hadron Collider are looking for correlations in particle data, wondering if the gravitational ripple had quantum effects that were felt even here on Earth. Philosophers are questioning what it means for our place in the universe if we are merely a transit point for more advanced travelers. The psychological impact of knowing that it is possible cannot be understated. It is the 4-minute mile of the cosmic age. Once we know it can be done, it is only a matter of time before we try to do it ourselves. In the coming years, more probes will be launched. The Vera C. Rubin Observatory will soon come online, capable of surveying the entire night sky every few days. We will find more interstellar objects, we will look for more ripples, but nothing will ever quite match the shock of 3I/ATLAS. It was the moment the impossible became a data point. It was the moment the stars stopped being distant and started being reachable. As you look up tonight, remember that the sky isn't a ceiling, it's a vast elastic ocean. And something just made a wave. We must also consider the silence of the agencies. When Oumuamua passed, there was a flurry of public papers. With 3I/ATLAS, the silence is deafening. This often happens when data suggests something that has national security implications. If gravitational manipulation is possible, it isn't just a tool for space travel. It's the ultimate power. The ability to control the very geometry of the world would be the most significant discovery in the history of our species. It is no wonder that the data has been moved to secure servers. We are likely looking at the start of a new space race, one not for the moon or Mars, but for the fundamental secrets of the vacuum itself. Despite the secrecy, the truth has a way of leaking out. The micro distortions in starlight, the time dilation, the internal glow, these are facts that cannot be hidden forever. They are written in the light that reached our telescopes. They are part of the permanent record of the universe. And as more amateur astronomers and independent researchers analyze the public data that did manage to get out, the picture will become clearer. We are living in the era of the great reveal. The universe is pulling back its veil, and what we are seeing is more magnificent and more complex than we ever dared to imagine. So let us keep our eyes on the horizon. Let us keep our instruments calibrated and our minds open. The story of 3I/ATLAS is not over. It is just beginning. Every bit of data we collect as it leaves our system will be a piece of the puzzle. We may not have all the answers today, or even this decade, but we have the questions. And in science, the questions are the most important part. They are the compass that points us toward the truth. 3I/ATLAS has given us a new direction. It has shown us that the universe is not a static place of cold distance, but a dynamic, living fabric that can be shaped. As we conclude this exploration, think about the legacy of this moment. Think about what you will tell the next generation when they ask when we first knew. When did we first know that we weren't the masters of physics? When did we first know that the stars were within reach? You can tell them it was a quiet night in Hawaii at a telescope called Subaru, when a greenish glow turned into a ripple in time. You can tell them it was the night the universe spoke and we finally learned how to listen. The dark is no longer empty. It is full of potential, full of travelers, and full of whispers. Thank you for being part of this journey tonight. Your curiosity is what keeps this channel alive and what keeps humanity moving forward. We are all explorers in this together, drifting on our small blue marble through a sea of wonders. Keep looking up, keep asking why, and never lose that sense of wonder that makes us human. The universe is waiting for us, and it seems it has already sent its first invitation. Until next time, stay curious, stay vigilant, and remember, the truth is out there, hidden in the folds of space and the passage of time.